All right, let's talk about Lewis structures. So in your lab, the example given for you is the Lewis structure of phosgene, which has the chemical formula COCl2. So how can we draw this? So the first thing we need to do is figure out how many valence electrons there are. And we know this is made of carbon, oxygen, and chlorine. Now, carbon is a row 4A or 14 element. That implies that it's going to give us 4 valence electrons. Now, in the molecular formula here, the chemical formula here, we see that there are only 1 carbon, so that means that all in all, carbon contributes 4 valence electrons. Similarly, with oxygen, we're in row 6A or 16. Which tells us that it's going to contribute 6 valence electrons. Again, there's only 1 oxygen here, so that's an overall 6 valence electrons. And last, we have chlorine, which is a row 17 or row 7A. That means it's going to contribute 7 valence electrons. There are 2 of them for a total of 14 valence electrons from chlorine. And that's going to give us a total of 24 valence electrons. Next, we have to determine the central atom. So the general rule of thumb on this is the central atom is always going to be the atom with the lowest electronegativity. In this case, we're looking at carbon, because it's the least electronegative. It can also form the most bonds. Now we're going to assign our electrons. And to do this, we are going to draw our central atom, which is carbon, and then surround it with all the other atoms. So this is, we're going to connect them with bonds. And so each bond is worth 2 electrons. So we have 2, 4, 6 valence electrons used here. That means we have 18 valence electrons left. And we can now check to see if the octet rule for each of these has been satisfied. So carbon, oxygen, chlorine, and chlorine. So carbon here has 2, 4, 6 electrons. It needs 8, so no. Both these chlorines and the oxygen only have 2 valence electrons right now, so none of the octet rules have been fulfilled. So to remedy this, we're going to start distributing in our extra valence electrons. So we have 18 valence electrons to distribute. So let's start with the chlorines. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. Now, you'd usually want to distribute that evenly, but we know it's going to work out. So now we can say all 24 valence electrons have been used. There are no valence electrons left. We'll look at the atoms and check their octets. So carbon still only has 6 electrons, so its octet rule is not satisfied. Oxygen has 2, 4, 6, 8, so its octet is satisfied. Chlorine, 2, 4, 6, 8, 2, 4, 6, 8. Both chlorines have their octet satisfied. So we just need to fulfill the octet on carbon, and to do that, we'll just move electrons, one of these lone pairs of electrons, down and form a double bond from oxygen. So now we have 24 valence electrons used. Still have none left over. We can check the octets on each of them. Carbon, oxygen, chlorine, and chlorine. Chlorines both have theirs fulfilled. Now carbon has 2, 4, 6, 8, so carbon's is now fulfilled, and oxygen has 2, 4, 6, 8. So octet rules are all fulfilled. Now we can start thinking about the shape of this. So I've brought a new piece of paper out and drawn the Lewis diagram that we just generated. And we're going to try to make a model out of this with a model kit. And to do this, I have these balls and stick models. I have a black ball, which represents carbon. Let me just put this here. I have a red ball to represent oxygen. And I have these 2 green balls to represent chlorines. And we see that carbon is got 1 bond between each chlorines, so we'll just use these sticks to represent those single bonds. And we see that there's a double bond on oxygen, so we're going to use these flexible sticks for that. And let's just build this out. Alright, so there's our model. You can see that the relationship of the carbon and oxygen is linear. And we have this kind of bend here on the carbon between the chlorines. This is called trigonal planar. Now another way we can figure this out is by looking at the bonding around the central atom. So we're going to look at each of the bonding domains. So here we have 1, 2, 3 bonding domains. So we have 3 bonding domains. Well, 3 domains total. 1, 2, 3. These are regions where around the central atom that have pairs of electrons. But we only give double bonds a single value. So even though it's a double bond, we don't count it for 2. It's just 1 domain. So 3 domains. All 3 of them are bonding. There are no lone pairs or non-bonding. And so you can look in your lab write-up, and there's a table, and you'll find that when you have 3 pairs that are all bonding with no lone pairs, this matches up with a trigonal planar geometry.